My dear student, I am A.K. HAZRA from Salt Lake City, Kolkata. I wholeheartedly welcome you to School of Fundamental Sciences for our confidence building program. This intensive program will help you a lot to understand the fundamental concepts of physics, chemistry, mathematics steadily. I earnestly request you to study the content of our videos very carefully. I will be happy if you understand and enjoy the useful concepts. My heartfelt wishes for your bright future. Thank you. My dear students, let us start the concept of average molecular mass or molar mass. First you see results in terms of mass and moles. So average molar mass, clearly total molar mass has the dimension gram per mole. So total mass divided by total number of moles. So it will be gram per mole thing from dimensional point of view. Average molar mass means what? Total gram per mole mixture. So total mass by total number of moles. By symbol you can write m bar equals to m total mass of the mixture divided by total number of moles of the mixture, average. We can also find in terms of molar mass and moles. How? Let us see. If capital Mg represents molar mass of a gas G and small ng amount, that is number of moles of the gas G, then average molar mass equals to what? N into m. It is the mass of A. From dimension you think mole, capital M is what? Gram per mole. So mole can cancel gram. So N into m means what? Mass of a gas A plus Nb into Mb, mass of the gas B, plus so on by total number of moles Na plus Nb. By sigma concept also you can write sigma Ng by sigma Ng. Sigma means Ma small na capital Ma plus Na Nb, sorry, sigma means what? Na Ma plus Nb Mb plus Nc Nd and so on. Similarly sigma Ng means Na plus Nb plus Nc and so on. So we can have in terms of these also you see explanation. That is the standard result, total mass by total number of moles, first result. So m total by m n total. So m total means Ma plus Mb, small m implies mass, Ma plus Mb dot small n implies number of moles, so Na plus Nb. Now M is equal to what? Na Ma plus Nb Mb dot because mass equals to small n into capital M. From dimension you think mole gram per mole. So mole cancel gram. So Nm has the dimension gram. That's why it is a mass. So this mass is replaced by this mass is replaced by that, by Na plus Nb dot. Yes, so the sigma concept already explained result 2. Now third result in terms of mole fraction. If Xg implies mole fraction of gas G, then yes, the average molar mass equals to mole fraction of A into molar mass of A plus mole fraction of B into molar mass of B. So also you can apply sigma concept. Sigma Xg Mg means Xa Ma plus Xb Mb and dot. Explanation. You see the previous result, average molar mass Na Ma plus Nb Mb dot by total number of moles Na plus Nb. So also you can write Na Ma plus Nb Mb plus dot by n total equals, we can write Na by n total into Ma plus Nb by n total into Mb and dot. Na by n total means you know mole fraction. So mole fraction of A into Ma. Nb by n total means mole fraction of B. So mole fraction of B into molar mass of B and dot. Now sample problem 15. A gaseous mixture contains helium and oxygen, and their average molar mass of the mixture is given 12.30 gram per mole. So we have to find the percent by mass of helium in the mixture. Let X be the mole fraction of helium in the mixture. Then you see equation number 063. Average molar mass equals to mole fraction of helium into molar mass of helium plus 1 minus X, that is called mole fraction of oxygen into molar mass of oxygen. It is given 12.30 gram per mole. Now mole fraction of helium X, molar mass of helium 4 gram per mole, equals to 1 minus X, molar mass of oxygen you know 32 gram per mole. Now gram per mole, gram per mole, gram per mole cancel out. So we'll have 12.30 equals to 4x plus 32 minus 32x equals to 32 minus 28x. So 28x equals to 32 minus 12.30 is equal to 19.70. So x equals to 0.074. But already I have explained, you see, mole fraction has dimension. So clearly we can write x equals to 0.74 mole helium per mole mixture. It will help us to solve the to find mass percent of helium. You see how mass percent of helium equals to what? Mass of helium by mass of the mixture into 100%. Now what is the mass of helium? Now already mole given 0.704 mole helium. It is given. Converted to mass, we know 4 gram helium, 1 mole helium. So mole helium cancel out. We will have mass of helium. Divided by, yes, 0.704 mole helium per mole mixture. So mixture is 1 mole and the average molar mass of the mixture is already given. 1 mole mixture is equal to 12.30 gram mixture. So that is the mass of helium and that is the mass of the mixture. So it is the mass of helium per gram mixture into 100%. So 12.89%. Next 16. Air contains nitrogen 78%, oxygen given, argon, carbon dioxide, all by mole, percent by mole. We have to compute the average molar mass of the air. So right, ratio of number of moles of N2 is to number of moles of O2 is to number of moles of argon is to number of moles of carbon dioxide. You see, 78 is to 21 is to 0.90 is to 1.10. You add, it will be actually, yes, it will be 100. Total 100. 78 plus 21. So 99 plus 1. So 100. So 100 mole contains 78 mole nitrogen, 21 mole oxygen, etc. Then from equation 062 we can have what? Average molar mass of air is equal to 78 mole nitrogen into molar mass of nitrogen 28 gram per mole. Mole cancel, will have a mass, plus oxygen 21 mole, molar mass 32 gram per mole. Mole cancel, 21 into 32 mass of oxygen. Similarly 0.90 mole, 0.90 mole carbon dioxide into carbon dioxide, you see 0.90 mole, sorry, argon 0.90 mole argon. So 0.90 mole argon molar mass 40 gram per mole and 0.10 mole carbon dioxide and molar mass is 44 gram per mole. It is the total mass of the mixture divided by total number of moles of the mixture. 78 mole plus 21 mole plus 0.90 mole plus 10 mole. So gram per mole, approximately 29 gram per mole. It is the average molar mass of air. SP 17. A sample of potato starch was ground in a ball mill to give starch-like molecule of lower molar mass. The product analyzed 0.0775% by mass of phosphorus. Relative atomic mass of phosphorus is given 31. If each molecule is assumed to contain 1 atom of phosphorus, so what is the average molar mass of the material? So this is already given. 1 mole material is assumed to contain 1 mole phosphorus atom. Yes, you see, if each molecule assumed to contain 1 atom of phosphorus, so clearly if each molecule becoming mole, it will also be mole. So 1 mole material assumed to contain 1 mole phosphorus. So we are going to find the what? Average molar mass of the material. How? What is given? 100 gram material by 0.0775 gram phosphorus. It is 0.775 mass percent phosphorus means what? 100 gram material contains 0.775 gram phosphorus. So material by gram phosphorus. Now we'll find, yes, it will be what? Gram per mole. So 1 mole material, and already explained you see 1 mole material contains 1 mole phosphorus. 1 mole phosphorus means what? 31 gram phosphorus, because relative atomic mass is what? 31. So 31 gram by 1 mole material. So you will have the what? Gram phosphorus cancel out. We will have 40,000 gram per mole. This is the answer, average molar mass. Now average molar mass of gaseous mixture of carbon monoxide and carbon dioxide is given 36.9 gram per mole. So compute the mole percent of the components in the mixture. So let N1 and N2 be the amounts of carbon monoxide and carbon dioxide in the mixture. Then we can apply average molar mass concept. Number of moles of carbon monoxide into its molar mass 28 gram per mole, plus here actually for calculation if we write dimension it becomes a little bit complicated, that's why we have avoided dimensions, but we must have same result, no problem. So N1, that is the amount of carbon monoxide into its molar mass 28, actually mole gram per mole, so it is the what? Total mass. Similarly plus N2, the amount of carbon dioxide 44, so N2 mole 44 gram per mole, so actually it is the mass of carbon dioxide. By total number of moles is what? N1 plus N2, it is given 36.9 gram, average molar mass it is given in the problem. Now calculate 28 N1 plus 44 N2 is equal to 36.9 this. Now if we calculate we will have this one, N1 by N2 is equal to 7.1 by 8.9, approximately 0.80. So we can add 0.80 by 1.00. Then we can have ratio, concept of ratio, N1 by N1 plus N2 is equal to what? 0.80 by 0.80 plus 1.00, the ratio concept. N1 corresponds to 0.80, N2 corresponds to 1.00. So your left, the treatment on the left side and the right side must be exactly same. So N1 by N1 plus N2, N1 corresponds to 0.80, N1 means corresponds to 0.80 plus N2 corresponds to 1.00. So we will have this one, this is simply 8 by 18, so 4 by 9. So it is the what? Mole fraction, N1 by this. And how to find the mole percent? Multiply 100. 4 by 9 is a what? Mole per mole mixture multiplied by 100. We will have a percentage. So it is a mole, actually it is a mole fraction of N1. So mole percent of carbon monoxide is what? 4 by 9 mole fraction into 100% is equal 44.44%. And that of carbon dioxide, 100% minus 44%, 44.44%, so 55.56%.